In section 4.3, we're looking at applications of systems of linear equations. So we're going to be applying word problems to systems of linear equations, whether it's 3 variables or 2 variables. So for equation number 1, for the paleontology lecture on campus, advance tickets cost $5 and tickets at the door cost $6. The ticket sales this year came to $4,540. The department chair wants to raise prices next year to $7 for advance tickets and $9 for tickets at the door. He said that if exactly the same number of people attend next year, the ticket sales at these new prices will total $6,560. If he is correct, how many tickets were sold in advance this year? How many tickets were sold at the door? So we need to pick 2 variables and let one be the number of advance tickets and the other one be the number of door tickets. So I'm going to let X be the number of advance tickets and I'm going to let Y be the number of door tickets. So let's go ahead and come through this word problem and figure out how to set up our equations. So the first thing that says, for the paleontology lecture on campus, advance tickets cost $5 and tickets at the door cost $6. The ticket sales this year came to $4,540. So let's go ahead and write that as an equation. So it would be 5x plus 6y equals 4,540. I'm going to label this as equation number 1. Let's go to the next one. The department chair wants to raise prices next year to $7 for advance tickets and $9 for tickets at the door. He said that if the exact same number of people attend, the new prices are going to total $6,560. So let's go ahead and write the new equation. That's going to be 7x plus 9y equals 6,560. And that's equation number 2. So now that we have our system, we can solve this so that we can figure out what x and y is, or how many advance tickets were sold and how many door tickets were sold. So we need to eliminate one of the two. I would say the addition method / elimination method is probably the best bet here. And I'm going to get rid of x. So I need to make 5 and 7 look the same. So I'm going to make equation number 1 have a negative 35 by multiplying by negative 7, and equation number 2 look like positive 35 by multiplying by 5. So equation number 1, let's go ahead and multiply by negative 7. So we end up with negative 35x minus 42y equals negative $31,780. We're going to multiply equation number 2 by positive 5 because we need to have positive 35. So we get 35x plus 45y equals 32,800. And we are going to add these together. So negative 35 and 35 are going to cancel. Negative 42 plus 45 gives me 3y And negative 31,780 plus 32,800 gives me 1,020. And so to get y by itself, we just need to divide both sides by 3. And we get y is equal to 340. Now remember, y is equal to the number of door tickets sold. So that means there was 340 tickets sold at the door, or door tickets, however you want to write it. We still need to figure out x, because I want to know how many were sold in advance. So we can plug into equation 1 or equation 2, it does not matter. I am going to plug into equation number 1, since the numbers are a little bit smaller. We have 5x plus 6 times y, which we found was 340, equals 4,440. So let's simplify. That's 5x plus 2,040 equals 4,540. We want to get x by itself, so we're going to subtract 2,040 from both sides. And so we get 5x equals 2,500. And dividing by 5 to get x by itself. We get x equals 500, and that's the advance tickets. So 340 tickets were sold at the door, and 500 were advance tickets. Let's try example number 2. An electronics firm makes 2 types of switching devices. Type A takes 4 minutes to make and requires $3 worth of materials, and type B takes 5 minutes to make and requires $5 worth of materials. When the production manager reviewed the latest batch, he found that it took 35 hours to make these switches with the materials cost of $1,900. How many switches of each type were produced for this latest batch? So a lot of times the last question is what you are looking for. So we want to know how much of each type were made. So I'm going to make things easy, and I'm going to say let A be the number of type A made, and I'm going to let B be the number of type B that were made. So we have 2 different things that are being talked about in here. We have the amount of money, and then we also have the time. And so money has to go with money, and time has to go with time. We can't mix these two because they are 2 very different things. So talking about type A takes 4 minutes, and type B takes 5 minutes. And total, we have 35 hours. Type A is $3. Type B is $5. and we have a total cost of $1,900. So let's go ahead and start with the money. So this would be 3A plus 5B equals 1,900. That's equation number 1. And now let's talk about the time. So it's given in minutes, but then the total was given in hours. We need this all to be the same unit. So we need to convert 35 hours to minutes for this to work. So the left side of the equation is just going to look like 4A plus 5B is equal to, we have our 35 hours, but we need this to be in minutes, so we're going to multiply it by 60. And this is equation number 2. So let's go ahead and just simplify equation number 2. You get 4A plus 5B equals 2,100. So now we're ready to go, and we can use the addition method or the elimination method, which is the same thing. So which variable would be really easy to get rid of? It would be really easy to get rid of B, because all we have to do is multiply either 1 or 2 by a negative so that we can eliminate these. So I'm going to multiply equation number 2 with our negative. So equation number 1 is going to stay the same. In equation number 2, we're going to multiply by negative 1. So we get negative 4A minus 5B equals negative 2,100. And so when I add the b's, they're going to cancel. We end up with negative A equals negative 200. But when I divide by negative 1, we get that A equals 200. Now A was the number of type A that were made. So there were 200 type A switches made. Now we need to figure out B. Doesn't matter which one I plug into, I am going to plug into equation number 2 though. So we know A is 200. So simplifying, we end up with 800 plus 5B equals 2,100. Subtracting 800 from both sides. We get 5B is equal to 1,300, and dividing by 5, we get B is equal to 260. So that means that 260 type B switches were made. Let's try another one. A trucking firm has 3 sizes of trucks. The large truck holds 10 tons of gravel, the medium truck holds 6 tons, and the small truck holds 4 tons. The firm has a contract to provide 15 trucks to haul 104 tons of gravel. To reduce fuel costs, the firm's manager wants to use 2 more of the fuel-efficient large trucks than the medium trucks. How many trucks of each type should she use? So again, we want to set up our variables. We have a small, medium, and large truck. So let X be the number of the large truck. You can let Y be the number of the medium truck. And we're going to let Z be the number of small trucks. So let's go ahead and pick apart this word problem. So the one thing that stood out to me was the fact that the firm has a contract to provide 15 trucks. So it doesn't say how much of each truck, but the total number of trucks between all 3 is 15. And so we can write that as X plus Y plus Z equals 15. And that'll be equation number 1. The next thing we have is the amount of gravel that each truck can hold and the total amount we were going to use. So the large truck holds 10 tons of gravel. The medium truck holds 6 tons, and the small truck holds 4 tons, and the total amount of tons we want to have of gravel is 104. And so we can set up this equation. This is 10x plus 6y plus 4z equals 104. And we have one more equation that we can write down. It says to reduce the fuel cost, the firm's manager wants to use 2 more of the fuel-efficient large trucks than the medium trucks. So how would we write that as an equation? 2 more of the fuel-efficient large trucks. So that means X is equal to 2 plus Y. 2 more than the medium trucks is how much we're using for the large trucks. And that's equation number 3. So how do I solve a system that looks like this? Well, the first thing that I would do is I would rewrite equation number 3 so that it looks very similar to the other 2 that we already have. So I'm going to move y to the other side, and we get that x minus y equals 2. And so we can see that in equation number 3, we are missing z. Z is not talked about. So we need to fix equation 1 and 2 by eliminating z. So to eliminate z with equations 1 and 2, I would need to multiply equation number 1 by -4. So I get negative 4x minus 4y minus 4z equals negative 60. And equation 2 is going to stay the exact same. 10x plus 6y plus 4z equals 104. So when I add these together, the z's are going to cancel like they're supposed to. We end up with 6x plus 2y is equal to 44. And I'm going to label this as equation number 4. Well, we can use the addition-elimination method with equation 3 and equation 4. And so the easiest variable that looks like we could eliminate would be y. So I am going to multiply equation number 3 by 2. So we get 2x minus 2y is equal to 4. And equation number 4 is going to stay the same. So your y's cancel. You end up with 8x equals 48. And we want to divide by 8. And we get that x is equal to 6. And that was the large trucks. So we have 6 large trucks that are being rented. What about the medium and the small trucks? Well, we can plug our x into equation 4 or 3 to get the other variable. So I'm going to plug it into equation number 3. We end up getting 6 minus y equals 2. We're subtracting 6 from both sides. We get negative y equals negative 4. And dividing by negative 1, we get that y is equal to 4. So that's 4 medium trucks. And we just need to figure out how many small trucks we're going to use here. So that means that we can plug our x and y into any of the equations to find out z. And so let's just go ahead and plug it into equation number 1, because it's the simplest one. We end up with 6 plus 4 plus c equals 15, or we get 10 plus z is 15. And when I subtract 10 from both sides, we get that z is equal to 5 small trucks. Let's go ahead and try one more. Florida Fruits packs 3 types of gift boxes containing oranges, grapefruit, and tangerines. Box A contains 12 oranges, 5 grapefruit, and 3 tangerines. Box B contains 10 oranges, 6 grapefruit, and 4 tangerines. And box C contains 5 oranges, 8 grapefruit, and 5 tangerines. The shipping manager has 91 oranges, 63 grapefruit, and 40 tangerines. How many gift boxes of each type can she prepare? So again, that last question tells you what you should let your letters be. So I'm going to let A be the number of box A. I'm going to let B be the number of box B. And I'm going to let C be the number of box C. Now, just like in one of the previous ones, minutes went with minutes and money went with money. Well, in this case, we're talking about oranges, grapefruit, and tangerines. So that means that oranges have to go with oranges, grapefruit goes with grapefruit, and tangerines go with tangerines. So for our first equation, we have 12 oranges. We have 10 oranges. We have 5 oranges. And we have a total of 91 oranges. So let's go ahead and write that equation down first. So 12 in box A plus 10 in box B plus 5 in box C for a total of 91 oranges. Now let's look at grapefruits. We've got 5 grapefruit, 6 grapefruit, 8 grapefruit, for a total of 63 grapefruit. So same idea. We've got 5A plus 6B plus 8C equals 63. The last thing is tangerines. We've got 3 tangerines, 4 tangerines, and 5 tangerines for a total of 40 tangerines. So we have 3A plus 4B plus 5C is equal to 40. And so the best method here is to do the addition elimination method. So looking between all three, it looks like equation 1 and equation 3 would be pretty easy to eliminate Z. I just need to multiply one of them by -1. So the first thing I'm going to do is I'm going to leave equation 1 just as it is. And I'm going to multiply equation 3 by -1. So I'm just going to change the signs. We've got -3A minus 4B minus 5C equals -40. And so the C's end up canceling. We've got 12A minus 3A, which is 9A. 10B minus 4B, which is 6B, is equal to 91 minus 40 is 51. And this is going to be equation number 4. Now we need to compare two other equations, but we still want to eliminate C. So I'm going to compare equation 1 and equation 2, and I want to make C looks like 40. So I'm going to multiply equation number 1 by 8. And so we get 96A plus 80b plus 40c equals 728. And I'm going to multiply equation 2 by -5 so that I can get -40. So we end up with -25a minus 30b minus 40c equals -315. And so the c's end up canceling. And we end up with 96 minus 25 is 71a. 80 plus -30 is 50b equals 728 minus 315 gives me 413. And that is equation number 5. We now want to do this process with 4 and 5. So do we want to eliminate A or B? Which one would be easier? Honestly, either one is not going to be that easy, so I'm just going to eliminate A. I need to make 9 and 71 look the same. And so the common one that I could find was 639. So I'm going to multiply equation number 4 by 71. And we get 639a plus 426b equals 3,621. I'm going to multiply equation number 5 by -9. We get -639a minus 450b equals -3,717. And so when I add these together, the a's end up canceling, and we end up getting -24b equals -96. And when I divide both sides by -24, we get that b is equal to 4. So that's 4 type B boxes. Now we need to figure out how much of type A and type C. So I can plug in this information for B into either 4 or 5. It doesn't matter which one. I'm going to plug it into equation number 4. So we have 9a plus 6 times 4 equals 51. Well, that's 9a plus 24 is 51. We can subtract 24 from both sides. And we end up with 9a equals 27. And when I divide both sides by 9, we get that a is equal to 3. So that's 3 type A boxes. We just need to figure out C, and it doesn't matter which one we plug into. So I'm going to plug into equation number 3. So that's 3 times 3 plus 4 times 4 plus 5c equals 40. This ends up giving me 9 plus 16 plus 5c equals 40, or we get 25 plus 5c equals 40. We can subtract 25 from both sides. And we get that 5c is equal to 15. And when I divide by 5, we get C equals 3, and this is type C boxes.